In this section, we're going to talk about auxiliary information for improving the estimates we have. But before we do that, one thing I forgot to do at the end there of the last video was to save this session of QGIS. We've got some nice colors here. We've got a layer loaded in here. We want to be able to save this project. So please go to the menu, Project, Save As, and navigate to wherever you're saving your things on the Windows side. This is not something you're going to need later on unless we have a crash or something, which happens quite a bit with QGIS. I save C colon INAHOR, and then right here I'm going to call this let's say module 4, and that'll just be a little backup right there. Okay, we're coming back to QGIS very quickly, but before we do that, let's take a look at this slide and think about some of the sources of auxiliary information which historically have been used and we're going to make use of in some form or another at one point. The high-resolution satellite images, if you can have these, they're probably the best. It's as if you have eyes in the sky looking down on your area to complement the SAR images. Now, the problem is, of course, clouds, that you may not actually have these images available for the period that you're interested in. That's why we're using SAR overall. They're very expensive. The high resolution comes with a very high price. But sometimes companies such as Google will purchase images and make them available for reference on platforms such as Google Earth or Google Maps. One major issue is that these images may not be concurrent. They may not be from the time that we're looking at, and that's a problem with Google Earth. Lower resolution satellite images, and by the way, I mean spatial resolution. Lower spatial resolution satellite images such as MODIS, Landsat, Sentinel-2, these are more easily accessible. However, of course, you have got the clouds issue. You've also got concurrency issues, but also the need to manipulate these in GIS. If you're not so familiar with this work, it might not be the easiest thing to go and grab these and process them and make use of them. But it's something that I think should be in all toolboxes somewhere along the line of making these decisions. And finally, ground truthing. This is probably, if you can do it, it's probably the best. Seeing firsthand, sending people out into the field, going yourself, taking pictures, notes during the time that the satellites are passing over for the SAR images. That's the best, but it's time consuming, takes a lot of budget. And in fact, one of the reasons we're doing this training in the first place is to cut down on the needs for these huge field surveys. So this should be taken right now as just a little note that we're going to talk about later on in this module. But the idea is that we can do smartly and get some good statistical information that we can expand to the whole area. Okay. So let's go back here to the Windows partition where we've got the output from the INAHOR model. We've got these colors, looks okay. Now, one of my absolute favorite parts of QGIS is the Open Layers plugin. This is an absolutely amazing plugin. If you don't have it yet, if you go to web and if you don't see this, you're going to have to go to plugins and click on plugins, go to manage and install plugins if you don't have it. This will bring up, you have to be connected to the internet for this. This should bring up a dialog. Okay, patience. I'm going to rest here. Okay, there we go. And let me clear this. I was just searching for it in advance. If you go to all and then type in open, layers, okay, you'll get a list of anything with those sorts of terms in it. And Open Layers plugin, I have it installed already. If you don't have it installed, I would like you to install it now. Click on this and then click on, it should be right here, install. And that'll take a few minutes depending on your internet speed. And when you're done with that, let's come back to this area where Open Layers plugin should exist. Now, the reason I'm talking about this is because of these options right here. OpenStreetMap, Google Maps, Bing, MapQuest, OpenStreetMap Stamen, and Apple Maps. For right now, let's look at Google Maps, and let's go to Google Satellite. This is like something we see in Google Earth. Many of you are familiar with that. You've seen a view like this, but now this view is right in the heart of your GIS. And this is absolutely amazing. If you toggle that on and off, you can see that, at least for this reservoir, let's zoom in here. You can get a very clear view that these areas are of the same area. Now note, this image is, let me actually zoom down here and see. This is Digital Globe. Oh, there's a lot of images here, depending on the area we're zoomed in, but this might be less than a meter, maybe half a meter resolution, so it's very fine. The INAHOR data was, at a much lower resolution. And if we zoom in here, and again, I mean spatial resolution, if we measure this, just the width of one of these pixels, we get, was it 25 meters? And that's what it was downsampled to. So in the Google Earth one, you're looking at, well, half a meter maybe for this image. Let me zoom out. So there are those issues, and there's also a mask applied here, so it's a little bit zigzag that you can see the, let me toggle that off. You can see zigzags right there, and that's fine. So the Google Earth image is really interesting because actually it's sort of, okay, did you see how that was faded a little bit? And if I move it, it reloads. There are some issues with loading and this plugin, but it's well worth the effort. Let's look at some parts here of the image and think about some of the possible errors that might happen. So for example, there's a nice area here just south of this reservoir, some mountains here. We've got a rice area here. Let me zoom in a little bit. Yeah, you can see patterns which look like rice farming with some trees in there perhaps. And then you've got mountains. There's no rice farming going on here, right? But if you check out what the INAHOR output says, let's go right here. This is the northwest facing side of a mountain, which when the satellite was passing over was relatively shaded just because of the illumination angle of the sun. This slope right here is facing towards the sun, so it's brighter. This is also brighter. And you'll remember in the INAHOR model that it's looking for darker parts of the image. That's considering lower backscatter. Now, often that's due to water, which is not going to be reflecting the signal back to the sensor, but in other cases it might be due to the angle of this land facing away from the sensor, which, even though there's trees here which would provide very high backscatter, it may not appear such to the pulsar sensor given where it is in its orbit. So if you turn this off, you'll see there are areas where it's saying this is rice. Now, we know it's not rice. This is one of the typical issues that we face when using the pulsar or any other remote sensing images. Let me just go through this list here first of some of the possible over or underestimations that happen in this case. Overestimation in dark areas, that's just what I mentioned. It might not be shadows on mountains. It could also be dark, wet soil areas, places that don't become rice but do look dark. There's underestimation in light areas. We'll take a look at this next, where near urban areas there might be farms, but for various reasons of the backscatter from buildings, you might have underestimation. Upland rice might be underestimated. Sometimes maize is mistaken for rice, or perhaps more understandably, wetlands may be mistaken for rice, in the sense that you've got maybe a flooded area where vegetation is not very clear. The flood goes down. You've got then a lot of vegetation coming through the wetland. That basically is a rice paddy in a lot of ways, and those will often be mistaken for rice and lead to overestimation of rice area. And one last thing here, the accuracy depends on the image date. There's just various characteristics which depend on the day. And there's nothing you can do about this or many of these issues, just something to be aware of. So let's go back to here and look around just a little bit more before we move on to the next section. And I'll leave this as a homework to you to pan around, to look and see if you can find some sort of interesting patterns. Like right here, we've got a city. If I zoom in a little bit, this is, how does this look? Yeah, more or less, there's no rice growing in the city. There are these areas, like right here, which have been categorized as rice by INAHOR. Well, they're trees or some other mix of something. And remember, the resolution is not really something that you can easily compare. The Pulsar 2 images are much rougher, and this is something we just have to live with. If you zoom out far enough, then the image becomes, the problems with the resolution become a lot less. Let me turn this back on one more time. I want to look down here at, there's a nice river area. We looked at it in one of the first lectures, module, what was that, module 1, I guess it was. Was it this area? No, it's down here, yeah. Yeah, okay, let's look right here. We've got this very nice river coming through here. You've got some rice in the floodplain area. You've got rice out here. You've got city down here. Let's see how INAHOR did for that. Okay. Yeah, it looks okay, more or less. But the problem is, and you can imagine just this rough cut we had with using minus 15 for threshold 1 and using 3 for threshold 2, certainly not necessarily the optimal amount. And if we look through here, yeah, we missed the city. We got some of the rice, well, most of the rice. It looks pretty good. But what we really, really need is, as we talked about in this PowerPoint, is this idea of ground truthing, to actually be on the ground, to take pictures, to see what's really going on during the time of overpass, or as close to it as possible. So that's where we're going to be turning our attention to very soon. The Google Earth materials or the Google satellite stuff will come in very handy when we are talking about making the surveys, because people, when they go out to the field, they need to have some good maps, and we're going to use this for that.